So we've talked about methods very abstractly, and now it's time to think about how we would actually specify a method. So let's go back to this idea of combining. A method that takes in two elements, flour and water, are supplied in this case. And in terms of how the method works, it's going to care about the type of its input. So I can't combine a steam engine with anything. That's not a combinable kind of thing, but flour and water are. And then the result also has a specific type. So combining flour and water produces dough, let's say, in this particular case. So let's take a look at a multiply method. Now, multiply is something Java can already do, but let's look at it as an example. And as a function kind of diagram, it takes in two integers, let's say, and then the result of that would also be an integer. So let's think about how we would actually specify this. So our multiply function is going to take in two elements. These are called arguments or parameters, and each of them is given a name. In this case, we'll call them C and D. And then the result of multiplying C and D would be their product. So in kind of cartoon form, we see 5 and 2 coming into a multiply operator, 5 and 2 being received as C and D respectively, and then the output is produced. In this case, it would be a 10. So let's look at how we actually write this in terms of code. So we see a declaration here of a method, and all of our methods are going to begin with the phrase public static. Just consider that idiomatic at this point. But then the important part that bears examination in more detail is after that, where we see highlighted here the signature of the method, which includes many different elements that I'll talk about one at a time. So the first thing to talk about is the name of the method. That's an important part of the signature. If we want to use the method, we have to know its name. And once we know its name, we can call it. And when we call it, we have to supply it its parameters. And that's the next part of the signature. So we have the name of the method, along with its parameters and their types. Really, the names of the parameters are not important. C and D could have been called X and Y, or any other kinds of variable names. It's the fact that they're both integers that matters. So the signature of our method so far is multiply, MPY, the name, and then int and int are the two parameters that are taken in. And the final part of the signature is the type of the result that's produced by the method, and in this case, that's also an int. Okay, so the method body contains the instructions that actually execute when the method's called, and when they get triggered and start to execute, the actual values of the parameters, in this case 5 and 2, can be viewed as being substituted directly for C and D. And this is the kind of substitution we're familiar with in algebra. So if C is a variable appearing inside the method, if I call it passing a 5, you might as well put a 5 everywhere you see C, and that's going to show you exactly how the method gets evaluated. So let's try that. Let's take the variable C and substitute a 5 for it. And we see that sum now becomes sum plus 5. And we'll do the same thing for D. So D has the value 2 associated with it. And so our loop goes from 0 up to but not including 2. And then in the end, the method will continue until it hits any kind of a return statement. This return statement happens to appear at the end of the code, but it could appear anywhere. And once the return statement is hit, it's like everybody out of the water. That's the end of the method, and the method is over. In this case, if we substitute the value of sum for the return value, we see sum at the end of the loop would be 10, and it would return 10. Now here we see a change to the method. This method has an if statement before the main part of the computation that checks to see whether D is negative, and if so, it returns 0. This particular implementation of multiply does not work if the second argument is negative. So we check for that, checking for D being negative, and if so, we return 0. If we substitute 5 for C, as shown, and substitute -1 for D, as shown, then when the if statement is evaluated, -1 is less than 0, and the method immediately stops by returning 0. And that's the end of the method. Nothing else in the method gets a chance to execute. So here we see a method for doubling an integer. And it just takes in one parameter. And we could return 2 times that parameter as the realization of the method. Or we can use another important principle in computer science, namely reduction, where we take a problem we already have a solution to, and we use it to solve a new problem. So if we don't know how to double a number, but we know how to multiply a number by 2, instead of multiplying the number by 2 directly, we can call MPY, the method we just implemented, and pass it in, and then the number 2, and it should do the job for us of doubling the number. Another example that we've seen before is trying to represent a double with 2 digits after the decimal point to clean up the kinds of doubles that might print out so that you just see 2 digits of accuracy. And the code for doing that is highlighted here, and it's a fairly complicated bit of code. And previously, if we wanted to use this code in 5 different places in our program, we'd have to copy and paste the code, and that's tedious and also error-prone. So instead, we can abstract it into a method, and we pass in the double we wish to realize as having just 2 digits after its decimal point, and in the end, we return a string which exactly has that representation in it. And we do this simply by shifting the number over by multiplying by 100, which moves the decimal to the right 2 places. Then we get a double result by dividing that by 100 and capture the result as a string. So these 3 statements, which we've actually seen before, are now realized as a method, and we can now use 2digs any place we like to in our code. And this allows us to get it right once and define the method and then call the method wherever we like.